Hello friends. In today's video, let us discuss about the long answer question from chapter Waves. In Waves chapter, the most important questions are first one, stationary waves in stretched string, right? The second one, stationary waves in open pipes. Third one, stationary waves in closed pipes. Fourth one, Doppler effect. Alright. So in old question papers, we find maximum these four questions. Other than these questions, Doppler shift as well as beats are there. But regularly, maximum these questions are repeated in old papers. Okay. So in today's video, let us discuss about the formation of stationary waves in stretched strings. Right? Now this is for future learners. I'm doing a small trial so that the future learners can read, understand, and write the exam perfectly. Okay. Now let us start. The first thing we have to remember is we must understand the question. Okay. The question is explain the formation of stationary waves in stretched strings and hence deduce the laws of transverse waves in stretched strings. First, what he said, the formation, underline, the formation of stationary waves in stretched strings. What he is asking? He is asking to explain the formation of stationary wave in stretched strings. After that, he is asking to deduce the laws of transverse waves in stretched strings. Right? So first, let us go for the formation. So I'm writing the notes along this video. Okay. Formation of stationary waves. Pause the video and just write down the notes. Formation of stationary waves. So maximum I'm trying to make you to read in a simpler way. Okay. So let us go in point wise. Another thing, point wise we have to read. The first point is, now here I took a string. It is fixed at both ends. Right? I took a string. It is fixed at both ends. Right? First, what we have to do means, now consider a string fixed at both ends. Right? We did it. Second point. Let us pluck in the middle. Pluck in the middle of a string. Right? When you pluck, what will happen? Transverse waves are generated. Right? So now, this transfer wave travel in such a way and reaches the other end. This we call incident wave. And here, as this is a fixed end, it reflects back. So in such a way, right? So what happens? This wave reflects at fixed ends, right? Now see how these waves are. This is in this direction. Let us assume A to B, and this is from B to A, reflected wave. This is incident wave, and this is reflected wave, right? How they are opposite to each other, how they are moving opposite to each other, right? So now, and they are traveling along same string only, no, we are not changing any string. Okay, so now see, these two waves combine and form a stationary wave. This we call a stationary waves. These reflected waves travel in opposite directions along length of string combine to form string and combine to form stationary waves. So this is the formation of stationary waves. I think it is easier for you, right? Now see, at the ends, what we are getting? Node position in between antinodes. So at ends, nodes are formed. Clear? Right? Now let us go for the explanation. Okay. So now here, consider two waves. Okay. Let y1, y2 be their displacements. Okay. Just remember y1. The formula for y1. y1 we will write it as a sine kx minus omega t. You just learn this. Practice. If you practice 2-3 times, you will get. y2 same. Write like this. Instead of minus, you place plus. So y2 equal to, because opposite direction, no? So plus, minus minus plus, a sine kx plus omega t. Right? This is for incident wave, this is for reflected wave, displacement of reflected wave. Right? y2 equal to a sine. Now next, apply superposition principle. According to superposition principle. So it will be easy. Y is equal to, we will write it as y1 plus y2. Now write these two. What is y1? A sine kx minus omega t plus, what is y2? A sine kx plus omega t. No need of by hearting here. You already wrote. You are just writing here. Right? Now if you go on doing all mathematical part, it will be critical to you. So directly we are writing answer. So you may ask how to remember the answer. Just put 2. Write this A. In these both, what is the first term? Sine kx. Write down. What is the second term omega 2 no omega t no? You write as cos omega t. Logically you remember. So 2a sin kx. And in place of omega t, we will write it as cos omega t. In such a way, logically you try to remember. Okay. Now you got the value of y. Now with this, we will find the nodes and antinode positions. So the first point, when x is equal to 0, lambda by 2, you write just so on. So amplitude becomes 0. What we will call? So we get node. Similarly, when x is equal to lambda by 4, so on. No need of remembering all, just 1 or 2. Amplitude becomes maximum. Amplitude maximum means we get antinode. Right? Antinode position. Okay. Now next, expression for frequency. First, let us find out expression for frequency. This is also very simple. First, draw the diagram first, which we have drawn at the formation. The same diagram. No need of by-hearting a lot. Right? Let the length of string be L. Okay? Here I am writing. Okay? Consider a string of length, what I said, capital L. Right? Now, next, the velocity of transverse wave in a string or along the length of string. Just remember this, under root T by mu, where T is the tension, mu is the linear density. Okay, if you want, write here T, the tension in string or applied to the string, mu, linear density. Alright? Okay. Now next, the main important point, the distance between any two nodes. Now this is 0 amplitude position, we call node. So now the distance between any two nodes is L. Here to here, no, L is equal to lambda by 2. So first let us write like this. From this, lambda is equal to, do cross multiplication. 2 will go this side. It becomes 2L. Okay. Lambda is equal to, I am sending 2 to this side. 2L. Now we are aware about the formula V equal to nu lambda. Velocity, frequency, wavelength. So from this we can write nu equal to V by lambda, no? Lambda I am sending to this side, it comes under as a denominator. Okay. So now the frequency nu equal to what we will write? V by lambda. So what is the value of lambda here we got? V by 2L. Okay. And nu equal to, what is the V? Under root T by mu. First you write 1 by 2L. I wrote this. Here in place of V, what I am writing? This formula, T by mu. Right? This we call it as fundamental frequency. What we will call? It is called as fundamental frequency. Right? Okay. If n modes are present, the same formula, I'm not changing anything, but just in place of 1 I'm writing some n. Same formula, C. Now let us write the modes of vibration. Right? The modes of vibration or harmonics. I will write it as harmonics. Okay, modes of vibration or harmonics. We are finding the harmonics and overtones. This no need of doing any maximum stress, just if n equal to 1, what becomes? Nu equal to 1 by 2L under root T by mu. Just in place of n I substituted 1. So this we call it as fundamental frequency or first harmonic. What we will call? First harmonic or fundamental frequency. Here the same thing we got, no? Now, if n equal to 2, right? Here just for our easy, I am writing 1 for 1. This is for 2. In place of n, what I will write? 2. The same formula. Right? Now 2, this total term is nothing but equivalent to nu 1, no? I will substitute nu 1. Right? Now how can? Okay, if you don't understand, again another step, let us write 2. 1 by 2L under root T by mu. Now in place of 1 by 2L under root T by mu, I can substitute nu 1, no? So 2 nu 1. This we call it as second harmonic or first overtone. Similarly, if n equal to 3, I will write nu 3 is equal to, in place of n, what I have to write? 3 by 2L under root T by mu. That is equal to 3. Same, in place of 1 by 2L under root T by mu, I am writing nu 1. This we call third harmonic or second overtone. In such a way, we can go on writing. So, by this we completed the formation of stationary waves in stretched strings, their modes of vibration. Now, what is the second part of the question? He is asking to deduce the laws of transverse waves. Now, let us go for the laws of transverse waves. Simple thing. Already here you derived the formula. Fundamental frequency, right? Here you derived the formula for fundamental frequency. So no need of by hearting. Just turn the page and write down the formula for fundamental frequency right here. Fundamental frequency 1 by 2L under root T by mu. The second thing what you have to know, L means the length of vibrating string. Okay. L means length. T means tension applied to the string. Okay. Mu means linear density of the string. You must know these three. Right? Now, first law. Okay. What is this? fundamental, we are finding the fundamental frequency in three laws. Three laws we will have. We are finding fundamental frequency of vibrating string. See, fundamental frequency of vibrating string. Here what we will do means T and mu are kept constant. So now when these are constant, here I am writing mu will be proportional to 1 by L. If it is in the denominator, we say inversely proportional. If in numerator, we say directly proportional. Now, L is in denominator, no? So, fundamental frequency of vibrating string is inversely proportional to, what is L? Length of vibrating string. When just write T comma mu are constant. Enough. First law completed. Easy. Now second law. In second law, now L completed, no? Now L and mu will be kept constant. T will be changed. So now same. Fundamental. Same I am writing, you see. Frequency. A small changes of vibrating string is now new. Okay, new. Now here, now L mu are kept constant. No. Now what I am changing? T. So proportional to root T. It is in numerator. So what we will write instead of inversely? What I am writing? Directly proportional to, what is T? Tension. But under root T is there, no? So what we will say that? Proportional to square root of tension. When, see, square root of tension when L comma mu are kept constant. Right? Here these are changing. Are kept constant. Here we used length. Here square root of tension. Right? Now next the third law. Okay. Now same. The fundamental frequency. Fundamental frequency of vibrating string is, now L completed, T completed. What is remained? Mu is remained. Right? So what I will write? Proportional to 1 by root is there. So root mu. So it is in denominator. So instead of directly, inversely proportional to, here root is there, no? So what you will write? Square root of, what is mu? Linear density. Linear density. When what are kept constant? L and T. L comma T are constant. Right? 2 will be constant, third will be varying. So you just note down these small changes. Here the square root of linear density. And read down. So this is about the long answer of stationary waves in stretched strings. Underline that, stretched strings. And the laws of transverse waves. Now this is for future learners to make them read, write the physics long answers in an easier way. If you like these videos, Please share it, subscribe it. Yours, Reshma Physics. Thank you.